Well, I hope everybody got a lot out of that webinar. Definitely let everybody know we're in the process of actually updating it, kind of bringing it into the 2015 era. A lot of the information is going to be the same, but it's definitely going to be something that's going to be more up to date. One of the things I wanted to do was introduce myself. I'm Jason Spangler. I am the division manager for flooring, responsible for both the Rapid RH and our line of wood hand meters for testing moisture content in wood. As I go through this Q&A process, definitely don't hesitate to shoot me emails so that I can actually respond to them. And if for some reason I'm not able to get to all of them, I will definitely reach out to each one of you individually and try to answer the questions the best that I can. After we're through with this, if for some reason you do have additional questions, please don't hesitate to call me directly. My phone number is 800-634-9961, and my direct extension is 235. So without any further ado, we'll get off into the Q&A, and it looks like I have one, or the first one here is from Peter. It says, I do building investigations and often need to try and assess whether or not concrete slab subsoil continuity, whether there's a lack of a functional vapor retarder, is the source of moisture in a building. Short of an invasive visual inspection to determine the presence of or lack of a vapor retarder between the soil and the concrete slab, is your RH meter appropriate for this determination, especially in comparison to doing a pin moisture meter reading 1 or more inches down into the slab? Well, what I can say, Peter, that's a great question. What I can say is that there are a lot of people who do forensic analysis, whether it's for the entire building or specifically just for a flooring failure, that do what they call profiling of the slab. And in profiling of the slab, and I'm not saying it's used separately from doing core samples like with what you're talking about, but they'll profile the slab where if you have a 6-inch slab, they'll drill down 5 inches, put a sensor down there. They'll move over, drill down 4 inches, and so forth and so on, so that they can actually get a profile of what the moisture conditions are like from the bottom of the slab to the top. A lot of times that will give them some fairly good evidence to determine whether or not the moisture is coming from the bottom up, which would obviously lend you to believe that there is some portion of the vapor retarder is compromised, or if the profile is fairly consistent, or if possibly it's higher on the top, so there's potentially an issue with moisture from the top down. So definitely there are people out there who use the Rapid RH for those types of processes. One of the questions I get a lot of is, how do you determine the thickness of the concrete slab? And I'll tell you that, obviously you want to look at, if you're looking at new construction documents, you want to pay attention to, information from the GC, things of that nature. Do as much due diligence, obviously, as possible, and construction documents are going to be the best place to start. On rehabs, you'll see that where people will, if they're having to do any kind of plumbing alterations for additions or moving of bathrooms, they'll have to trench the concrete slab in order to move that plumbing. A lot of times people will go in there and get an effective thickness of the slab while that trenching is being done, so it helps them to be able to install sensors down the road. Worst case scenario, there are people out in the field that are taking smaller diameter drill bits. So if you can do like a 1/4 inch diameter drill bit and drilling all the way through the slab. And when you drill all the way through the slab, the second part of what they will usually do is use like a pliable wire and make a J hook on the bottom of it, so that that J can then be pushed down that hole until it springs out at the bottom. You can kind of pull it up so you have a little bit of tension on it and mark it off with the Sharpie and determine where the bottom of that J hook is and where the Sharpie mark is to give you a reasonable approximation of what the slab thickness is, so you can calculate your 40% depth on that. Those are a couple of ways. Another question that I get a lot of about drill depth is from people who are doing elevated pan decking, where you have inconsistencies in thicknesses. You may have 2 inches on, on the narrow, on the shallow part, maybe 6 inches deep on the deepest part. Couple different ways. I mean, the one thing I'll say is that the ASTM standard is absolutely silent on this this scenario, but there are a couple of very viable ways that are being done out in the field. One is there are people that are isolating or identifying where those high spots in the metal are at. And you can very easily, with a fairly inexpensive metal detector that you can pick up at like a Home Depot or a Lowe's, you can use it much like a stud finder that you would use to identify wood studs in a wall. So you take that metal detector, put it on the surface of the concrete, scan it across the concrete, and it'll be strong. It'll have a strong enough signal to pick up the high spots, but it won't be strong enough to pick up the deep spots. So as you scan across, it'll hit the high spot, scan across a little bit more, hit the high spot, mark those 2 spots, and then drill right between them. That's going to give you a spot that's the thickest. So you're going to drill 40% of the thickest portion of that slab. That's one way. The other way that people are doing it, and a lot of conversations going on around it, is trying to come up with some kind of effective thickness calculation, whereas you would take the shallow part, the deep part, find a differential, add them together, and then drill anywhere on the slab. Right now, that's not something that I'm seeing a lot of, but there is definitely a lot of conversation out there just to make it easier for everybody. Another question that I have from Robert. The commercial roofing industry is starting to see the ASTM F2170 test included in specifications, most commonly when structural lightweight concrete is used. Are there any different procedures or characteristics when testing lightweight concrete? What I'm seeing, I mean, to answer your question, lightweight concrete in general, no, there are no differences. What you're seeing from a roofing standpoint, where it's kind of curious, is that most of the F2170 is geared specifically for interior slabs, although really all a roof is, or a roof deck is for the most part, is just an exterior floor slab. We have a lot of experience from the flooring side of construction with moisture issues in concrete. You guys on the roofing segment are just coming into that. I look to see a lot of changes, alterations, kind of morphing of the testing procedure potentially to better encompass and make it easier for you guys as roofing companies, manufacturers, installers to be able to utilize the product. I have people that are part of that are roofing consultants that are doing investigative work with relative humidity to determine cause of failure. And they have to do some of the things a little bit different than what you would typically do, just because of the fact that you're dealing with interior versus exterior versus interior. But no, in general, structural lightweight concrete, you're not going to see. Again, roofing side of things, you have a little bit different makeup as far as how they comprise the entire system. But lightweight concrete in and of itself, there is no difference. So it looks like I don't have any other questions. Again, if anybody does have any questions once we get done with this, please don't hesitate to contact me. My name is Jason Spangler. My phone number is 800-634-9961, and my direct extension is 235. Thanks, and have a great day.